Alright guys, quick video. I'm going to show you my setup at home. This is my car. Open the charge port. That is the J1772 plug. As you know, it doesn't support three-phase. There's only 3 pins there, so it's hot, ground. And then the control pilot, and you even see it says CP, and the proximity sensor. Down here, this is the CCS cover, so I open that up. That gives me the 2 big DC pins. So the connector does both your AC up top, DC down there. Put the cover back on. I'll show you my garage setup. There's Julia. This is a NEMA 1450. This is becoming the standard plug, it seems, in the EV industry. This is what Tesla has recommended for years, and I think because of them it's becoming sort of the standard. This is the same plug that you would find on an electric range, like an oven, or at an RV campground. Again, we have hot, neutral, right? So hot, this is your neutral, and that's your earth. And there's another plug that's similar to this. It's the 650, not the 1450. The 650 doesn't have the neutral, so you can't get 120 out of it. And really, we don't need the 120. The NEMA 1430 plug is almost identical, except instead of a round earth ground, it has an L shape. Or I'm sorry, it's the neutral pin instead of I think instead of a straight blade, it's an L shape, something like that. Well, one of the pins is just slightly different, and you can actually modify one to be sort of compatible with the other. So this normally just hangs here in my garage. Here's the other end of the 1450 plug. It goes down to this the box here. So I'm just going to plug this in. Alright, so this is a portable box. This is just happens to be clamped to the wall. But once it's plugged in, it gives me some information. This is a 40 amp, I guess it's technically a charging station. But it shows me the voltage. So we're 248 volts currently, the temperature, and any power that's flowing, and any fault status, right? Alright, so that connects the other end to our J plug itself. I'm going to plug it into the car. Now, you heard it, I don't know if you heard it on the video, but there was a click right after I plugged it into the car. So now we have a timer, power starts flowing, it's counting up the kilowatt hours, and you'll see the amperage here. The car's just about charged, so this might not ramp up. Oh, there it goes. I was going to say it should ramp up over time as the car requests more and more power. So it starts off, once the proximity connection is closed, the control pilot advertises how much power is available, which is 40 amps. The car won't pull 40 amps, so it's more than sufficient, so the car can pull its maximum speed. This, on my car, this would get to maybe 28-ish amps. If it goes to full tilt, the full 6 point whatever, or 7.2 kilowatts, something like that, is the max. Alright, so it is going to go all the way up. So that's about full charging speed on my car. Alright, so the box gives us that little information. It's not very big. I'll show you another one. So this one I have at another house here. It's just a different unit, but it's identical setup. NEMA 1450. It's got the J plugs, a little rubber cover on it for transport. This one isn't set to 40 amps. This one actually only does 32 amps, but can go to 24 and can go to 16 amps. So there's a little setting on it. You can actually shake the box or use a little like RFID card that you can swoop right there, and it switches through the modes. So if I take it to a location, or if I adapt this plug down to a lower amperage plug, I can set the box to a lower power. That will tell the car that it's a lower power, and then the car won't pull as much. So if I'm only on let's say a 16 amp, let's say I adapt it down to a 6 520 or even a 520 NEMA connection, I can push this box down to 16 amps, and then the car won't pull more than that, so that communication happens all automatically. This is what shipped with the car. This is from Ford. It's the same plug. It's a skinnier cable. This is a 515 plug, your standard household outlet. So this one isn't meant to run at 240. It actually happens to if you adapt this up. That wasn't always the case. So some of the older generation versions of this would fry if you plugged them into 240. This one actually doesn't. So I can actually get up to 2.8 kilowatts out of this or something if I adapt it up to 240, which is still a lot slower than the bigger guy there, but that's what Ford shipped. You mentioned extension cord. This is literally an extension cord here. That's just a, well, here's an adapter to a TT30. So this is also what's used in RVs. So this would get me from a TT30 down to that Ford connector there. And then I have one more, and there's dozens of these. This one is a 3-prong dryer plug, I believe. Yeah, I believe that's the case. So it's a 30 amp dryer connection. This would go to 240 volts. I have it written on there. This is just an adapter I made. So I just bought a replacement dryer plug and put a 515 or 520, I guess in this case, receptacle on it. So this will adapt me over to that plug. And it looks like I have another one as well, because I don't always carry this one, so I'm trying to adapt down to the Ford one, but this is what I was talking about. So this one will fit in a NEMA 1450 or a NEMA 1430, and the fourth pin there, the neutral pin, I've cut off and just put some silicone over top of. Again, this is just wired to a standard 520 receptacle there. So again, because that one actually does stay in the car. This one, again, I would carry if I knew I was going to use it, but that setup's kind of for the with all the adapters is kind of what I have for the emergency use. And then this is from Quick Charge Power. They're in they might be in Arizona actually, or California somewhere, San Diego I think. They make an extension. This is just a straight up J1772 extension. So this is a 20-foot 40 amp, I believe, extension cable. So if I get to a charging station and the station's free, but it's blocked by, say, another car or something like that, or I just can't get close enough to the station, I can extend it another 20 feet. Gives me a couple more parking spots down. So that's sort of the environment, and of course you could extend on the other end too. But this stuff. I mean, when you're in the 50 amp range, you need 6-gauge cable. Some of this stuff might be like dual 8-gauge or dual 10-gauge or something like that, but the cables get pretty thick. So it's not, you want to haul as little of this stuff around as possible. But that's sort of the setup that I have and that I can carry around. But it all goes through the J1772 plug. The CCS plug, again, is pretty much the same as this, but it has that extra bit on the bottom for the DC pins, and that's all wired in. So this whole housing is much bigger, kind of through here. And those are only at charging stations that are out and about. The proximity circuit, if you're wondering, I don't know if you can hear, but when I push that button, there's actually a switch in there. So when I push the button, it's a mechanical release, so I can pull the plug out, but it also drops the proximity circuit, and so as I pull this out, as soon as I push that button, it drops the proximity circuit, and that tells the car that the charger is no longer there, or is about to not be there, and the car will stop pulling. It should drop the amount of current that it's pulling. It might not get to 0, but it'll drop significantly as soon as you push that button, so you're not doing a hot disconnect. So that's the other thing you need to worry about if you do a straight plug and you went into the car directly somehow, is that you lose all those sort of the ramp up, the ramp down, those safety protocols, so you're not doing hot plugs and hot disconnects. So, all right, that's all for now. I'm going to put this on YouTube.